And 3, 2, 1. All right. Welcome back to the Shop Class Podcast. All right, I'm Mr. G. Tonight, we're joined, obviously, with our regulars. We got Duke in the house. Say hi, Duke.
I just waved, but I figured nobody can really see me wave. So.
No, because, yeah, exactly. You got to say something. Okay, we got Nick.
Present.
It's like roll call. It's like ridiculous. All right, tonight we got a special guest, Michael Anschel. Did I say it right?
Michael Anschel, that works. That's my name.
All right, are you here? Can I check you in?
You can check the box. I am definitely here.
Okay. All right. So he is a builder and green advocate, but I'm probably not going to do the best job at explaining what he does. But I want to get into this with our first question. We always ask every shop guest, did you have shop class growing up?
Ooh. I did have shop class growing up. So I had wood shop class in junior high school. And then I had small engine class in high school. So I've had tools in my life, but this was not a path that I ever sought to be on and never thought I was going to be a builder. No one in my family's in the trades, but I did have shop class and I'm thankful for it.
That's awesome. Yeah, I was doing some research before you came on the show tonight, and I found some incredible stories. You kind of took a little bit of a zigzag path, which a lot of us did. But I would say, can you describe, before we get deep into your background of how you kind of got to where you are, what would be the main thing you're known for? Is it the green installs, or is it that contracting business? Like, what would you say?
I think it depends on who you ask and which industry, right? I think we're most known for I think for our architecture and our design work is probably what we're known for first and foremost. We're pretty visible in the community. Our work doesn't look like other people's work, so they identify it as ours. Sustainability and green buildings, kind of a core function for us. And then the building science component, and I've been on the speaker circuit for a number of years, lecturing on that, and kind of pushing the envelope. At the same time, I'd say on the business side of our world, I've got a kind of sharp tongue for some of my peers on how they conduct business and ways in which we operate, and so I'm a bit of a pot stirrer on that side of things.
Nice. Yeah, I like that. That's good. You know, if you think about it, the podcast is for shop teachers. So this is kind of like an inspiration and see the pathway, and then maybe give some shop teachers ideas of what they could bring into their classroom, or maybe just building connections for their own classroom, and sharing ideas. So you want to get us started on can you give us your latest project? Like, what's going on now?
I've got 15 projects in construction. So the latest project, I can't give that to you.
Oh, okay. This would be like an amateur question to ask you. Okay.
Well, we've got a really cool project that is underway right now. It's actually being filmed as season 2 of the Building Resilience show for Pro Trade Craft. I don't know if I can do a plug for ProTradeCraft.com. They're a website with a lot of really good resources on how to do stuff and how to do it, kind of best practices all around the residential building world for the most part.
I've got the YouTube channel right here. Let's see. This is the series, Building Resilience. And you're going through the whole build. Is this the build you're talking about?
So this build we did during the heyday of COVID. So, started December of 2019 and completed it, many, many months later than it was supposed to be. We're in season 2. And so we've got another house that we've gutted the interior and did a lot of crazy structural work. Brought some new materials in, dealt with a lot of funky conditions that you find on a 120-year-old house. So we talk a lot about control layers, thermal control layers, air control layers, water control layers, vapor control layers, human and client control layer. So, yeah.
I really like this series. I got to tell you, I got to give you props because they're about 10 minutes long. And I don't know about the new series, but this one here. And it's kind of great because it's like you give the overview. We're with you while you're doing stuff, but also you're doing commentary. So it's kind of interesting and great for me, knowing almost nothing about these houses. I'm just watching people build their houses and talking about, like what you said, the thermal layers and thermal breaks. This is my favorite term now, the thermal break. I love that, which makes perfect sense because, yeah, you kind of have that in the car world too. Aluminum versus steel. If you got a stainless steel versus, all these things interact with each other. And especially when it comes to, believe it or not, when it comes to batteries, there's a lot of thermal going on. Mm-hmm. And the way you handle that thermal, you're basically building. You have to move the heat away, but you also got to keep them warm when it's cold. So there's a lot going on with that. So is this house? This was a very old house.
That one is. Well? I believe that was built in 1913 originally as a Spanish colonial, and when we're done with it, it's a very, very contemporary looking home. So we gave it a total facelift. But one of the things that we did that was unique with that one, we actually have 4 different wall types on a single structure, which is unusual. So in new construction, right, you pick an assembly, and that's usually the assembly that you roll with through the entire thing. And in this one, we had existing walls, we had new walls, and then we had, in the new walls, we had some shear walls, and then we also had some new wall firewalls. So in terms of complexity for the guys to understand, which thing to build in which location, I'd say it ranks kind of up there in terms of needing to use your brain. But it's really cool to see how adding one component changes the overall performance of that wall, whether it's adding stiffness to it, or it's adding, some kind of resistance, or it's, like the thermal break for existing walls. There's this fine line that we have to walk between adding insulation, which reduces our drying potential in an assembly. So, right, the more insulation I have in something, the harder it is to move energy across the assembly, right? So if the assembly gets wet, the amount of energy it's going to take to dry it out is that much more than if it had very little thermal resistance and I could pump it full of heat very quickly. Right? We got to
like if something's drying in the middle of something that you glued together, or
we're probably going in like way into the weeds really fast on a building assembly. But so you've got, let's say, you got the
let's go.
So he's got this big.
You probably have an animation somewhere.
There's definitely an animation of this somewhere.
I'll tell you what, I appreciate those too. We got this one here. You're dealing with the basement. I love this. This thing, and then this is so cool because then they put the layers on top, and then you can see them adding the insulation. Then you're back on the scene and you're actually explaining it.
By the way, kudos for all of this goes to Dan Morrison, who he actually is the guy who started Green Building Advisor. And then he went on to start this, and he creates the videos, he stitches it all together, he makes the animations. I'm just the talking head. So
Yeah, it's awesome though.
I saw a teacher yesterday. I had after school club. So in his club, he was in my club when he was in middle school. We do TSA. It's an after school like robotics club, but TSA is a bunch of other smaller competitions, CO2 cars, digital photography. There's green manufacturing, coding, um, stuff like that. And we started it because the kids only had tech ed for like shop class for maybe 22 days. So it's for the kids who wanted to take the class more rather than just those 22 days. Do it after school for a while, and it goes from like October till April. But so I asked about his son, and he said, "Oh, he's going to the MCTI. That's Monroe County Career and Technical Institute, who's the old VOTech. And a lot of times those VOTechs get bad names." And I said to him, "Well, what's he doing there?" He says, "Construction." I said, "Look, we have this shop class podcast," and I said,
Yeah.
"Started out as shop teachers, just talking, seeing what they're doing during the COVID." But there's another group of guys that come from the building sciences. One of the guys got his master's degrees in building science. I'm like, this stuff blows my mind. So you think of it just building's been done the same way for 100 years. No, it hasn't. These guys in the building sciences are reinventing building. And I'm like, he's got to stick with it because there's options for him, especially now with the green manufacturing out there, different types of solar panels, batteries, getting better. I'm like, let him stick with it. And I said, if not for anything else, look, he still has something to fall back on. He gets a job. He can do it in the summer. He still has almost like a trade. But this building science stuff is just blowing my mind lately. It's awesome.
It's inspired me because I'm in the position where I'm finally looking for a house. Right now I rent, but I'm like, maybe I could build a house. Like what? Why am I gonna buy someone's old car when I could get a custom car built, maybe for the same price? So
building science it's it's a legitimate field. It's filled with a lot of physicists, a lot of engineers. It is, I was just kind of glancing over my library. I've got a dozen or so books. I've got a book, this thick that just addresses water. The only subject, the entire book is about water and buildings. Building Science Corporation. They've made millions, many millions. Their employees, they consult all over the world looking at building systems and building failures. So like forensic building science is a whole industry path. Then there's the guys who do modeling. So all the computer modeling of assemblies to show how they're perform in different environments. So if I take this assembly with this this glass configuration and I place it this far from the ocean, and I figure in for salt factors and all this stuff, what's the likelihood that the assembly will fail? It's going to get wet. How will it dry? It's super complex stuff. Hey, I know that house.
that was going to be one of my questions. How do you calculate? So like, for instance, how do you calculate the envelope and the material and the exposure and stuff like that? So for instance, like with a part, let's say I'm going to make a part for something and I want to know if I twist it like this and I twist it like this, what's going to happen? And I could always do CAD, which is cardboard aided design. I could break it myself and kind of see what happens. And then we could run the simulations on a 3D modeling program called, let's say, SolidWorks, and that'll use what they call FEA, which is finite element analysis. But what do you do about a house when it has multiple layers and you're going to decide what R factor and whatnot? So, yeah, what do you do about the envelope? Like, how do you make these decisions?
Oh man, that's an awesome question. So you've got material sciences, right? That what you're talking about. Like you've got a part, and then you've got. So you had all these folks who were doing material science, right? But they didn't think about the relationship between the materials, right? So I'm a manufacturer, I make a product, I put it in the market. My research says my product will perform as X, Y, and Z. Then manufacturer B says, hey, I made this, let's say I made a fastener, right? My fastener's got this resistance against shear, and it's got this resistance against torque, and right? And I'm like, well, this is a bomber fastener, and this is a bomber element, and I'm going to put the two together, except that this one has copper in it, and this one has got zinc in it, or steel, or right, aluminum, and pretty soon we've got deck ledgers falling off the sides of houses, right? So it's the collaborative layers of these things, and I think in building science, what we spend a lot of time looking at is not so much how the structural nature of it, but more the physics of the wall and how energy, specifically energy, water, and air, will move back and forth across and in this assembly. Because when you heat your home, so you guys, some of you are in places where it's cold, right? I'm in Minnesota.
Yeah.
It's very cold.
Yeah.
In the winter. And so if it's minus 30 degrees outside and it's 70 degrees inside, what's the pressure differential, right? And where is that occurring? Well, it's occurring horizontally at the wall, right? And then up at the ceiling, right? Sorry, vertically at the wall and horizontally at the ceiling. Do they perform the same way? Is the pressure that's exerted at 1 foot off the ground the same as 20 feet off the ground? It's not, right? And so what difference does that make in terms of the things that we put in the wall with the kinds of pressures that are being put on that system to make sure that it's resilient enough to withstand those? Because it's what we learned.
I'm sorry, I didn't even think about it. You're right. You're talking about like upwards convection.
There's convection. There's we call stack effect. It's a little different. Convection's more like airflow, like water.
All right.
But yeah. And it's like a balloon. The inside the balloon is different than outside the balloon. Right? You blow up a balloon, it doesn't stay blown up, right?
Yeah.
What's happening? Well, there's a degree of porosity within the film that makes up that skin of the balloon.
Okay.
So we have to account for that, right? If you blow it up with hot air from your mouth and you take the balloon outside, you're going to have water inside the balloon now because the temperature dropped and the carrying capacity of those air molecules was reduced. And so it had to drop the water somewhere. Well, you dropped it in a vapor impermeable enclosure like a balloon. Now I have standing water.
Right.
Right. So
almost
I got
almost like
layers.
Wow. Oh, and so now this happens among the layers in the wall.
Got it. Exactly. So this is happening in your wall system. There's air and water moving through it.
I'm sure all the shopkeepers can relate, and all the tradespeople can relate to draining the bottom of the pressure tank, your compressor.
Yeah.
So you got hot air going in because of the pressure, and then the outside is cold. So then it's a cold steel outside with hot air on the inside, and you're going to get condensation. It's the opposite of a cold soda can on a hot day.
Yeah.
Yeah.
And if you're spraying paint, you know that if you've got moisture in the line, that's going to affect how the paint's going to spray, right? So if you're spraying insulation, same thing. If the material you hit is cold or hot and you're spraying with a cold or hot material and there's too much differential, what happens when the one material hits the other and the moisture tries to burn off? If it burns off too fast, does it bubble up?
Wow.
It's all the same stuff. It's just in a different package, you know?
So the assembly. Yeah. So you have to consider your layers. This is very interesting. And, I don't know what it is, but the way the people I've been surrounded with growing up could care less. But that's changing. That's changing because I had a friend of mine who was an arborist, and he got into the blower door situation with the energy audits.
That's cool.
And then he started doing audits for a while because New Jersey was incentivizing it for a couple of years, about 10 years ago, but they dropped it. No one cares anymore. And no, I don't keep up to date. I haven't heard anything lately. But it was very interesting to me that now they're concerned with what happens with the energy. But it's not just that. Would be a simple thing I can understand, which is, what do you do with, how do you hold on to the energy? But it's not just that. What about all the water, and what about the air? And then what about how you assemble your wall? Yeah.
Yeah.
Very, very cool. And make it look cool and do innovative things like the Sky Cove. So this is like, it's not easy to do what you're doing.
It's not easy. It's not easy. I would agree with that. I would there's so many great analogies that you could make. Again, I like cars, but I'm not a car guy. I mean, like, don't ask me to take apart your engine.
Bring it. Let's hear it.
So, servicing.
It's honestly the best way to teach.
Right? Find things that people can connect with. Right.
Yeah, I figured out my job is not actually to teach. My job is to make people go like this. They go, oh. And when they say, oh, there's something happening with their eyebrows. They're, oh. If you can do that, bam, you get paid.
So I had a 1976 Plymouth Volare.
I don't even know what that is. That sounds
back
cool.
when I was the Plymouth Volare. It's a great car.
I feel like Nick
Plant 6 engine.
All right.
Chevy Impala, anything from the 70s, anything really from the 60s or 70s. You open up the hood, you've got roughly 6 acres, of area to work with. You could put both of your children in there and still get your hands around and take the carburetor off.
Right.
And you could change the oil. Right?
Yeah.
The 90s show up and you need a special socket set from Honda to open up the cover. Yep. My car, I open the hood. It's very beautiful what I see. I have no access to the parts. And my car calls BMW and says, hey, I think I want to come into the service station now. Right?
Yeah.
It's a completely different thing. I don't know how many. I've got an infrared camera in my car, so it can see if there's wildlife on the side of the road in the middle of the night.
Oh my God!
Right?
That's cool. Actually,
there's a lot of computers. Right? When you think about what is a car, so think about what is a house. Well, a house built in the early 1900s was no insulation, very, very, very simple systems. Look at those big giant engines.
Yeah, look at how much room you got over here. You could put a whole engine over in this side and another one over here.
Right?
Yeah, it's crazy. Look at this. Look at how much room there is.
Oh, I've got one. Hold on a second. I've got a 19. Here's a good illustration for you.
All right. Yeah. The hammer.
You know how to use this, right?
Sure, I think.
Framing hammer.
Yeah.
Yeah. Nice waffle head on there so that, grabs the nail.
Okay.
You know how to use this?
Right. It's like a different.
They do the same thing.
Wow.
Right?
Yeah.
This one, if the head gets loose, I know how to fix it. When this one starts to act up, I need to understand how to take this apart and put it back together. I need to understand how to set the pressure on my tank. I need to understand how to set the pressure on my depth gauge. I need to oil this thing. This is much more complicated. And this is my old one. Now I've got a battery-powered one from Hitachi.
Battery powered. I didn't realize they were doing that.
Oh, battery powered. Everything is batteries now. I have an impact wrench. I've got a massive impact wrench. Delivers some 5,400 pounds of torque off of an 18-volt battery.
That's incredible. Things have changed. They got complicated. Wait, I have the same analogy for you. Hold on. Okay. I got something. Hold on. I got something. Where's my pistons at? Okay, well, everybody knows what a piston looks like, but this is the new piston, the battery.
Whoa.
How do you manage this? This is called an 18650. This is in your drills, but it's also in the floor of a Tesla. They've since upgraded a little bit larger size now, but this is it. How do you charge these? How do you manage them? What are they made out of? Who makes the best ones? Oh my God. Oh, look. This is it right here, man. The spark plug.
There we go.
And I just, this one came out of my Ranger. This is, before you had to worry about the electricity jumping down the side. And this is called carbon tracking. And now you'd have to worry about short circuits and battery chemistry, heating, cooling. What are you going to do to keep them safe? All that stuff.
Yeah.
Yeah, that's cool. This is the modern day throttle. No longer just a cable. It's a computer inside there. This is actually out of a forklift, but whatever.
Even think about like on military stuff, right? Fly by wire. I mean,
Yeah.
Even the reality is on most of your modern cars that stick shift, not the stick shift, but the when you're shifting, it's not doing what you think it's doing.
Yeah. Like the +1, -1.
or it's just I remember driving my the Fisker when that first came out.
Oh, cool.
I got to test drive that thing, and drive was a button, reverse was a button, and I was looking at it and I was like, really? And the guy said it's exactly the same system that's inside a Camry, but they just gave you a big plastic arm to make you feel like you were doing something.
That's funny.
And of course they switched away from it too now, right? Now you hit the drive button.
Yeah. So
you have nowhere to rest your hand now. I drive my wife's car and I'm constantly reaching for something, and then just find my elbows just sitting on the console now.
That's funny. Yeah, so basically, you have to manage understanding all these materials and the assembly. Now something came up called the awesome wall.
Yep.
What is the awesome wall?
The awesome wall is awesome.
Yeah. This is an assembly, right? This is an assembly.
Yeah.
That's why I brought it up. Yeah.
So in this like search for how to build better, we really been wrestling with, there's a system out there called the perfect wall. And it achieves a really high level of efficiency, but it's it's very, very complicated. And if the geometry of your structure has any complexity to it, it becomes very, very unworkable. And nobody wants to do it. Like it sounds cool, it looks cool, but every builder looks at it and says, no way. It's just too much of a departure from what we already know how to do. And so we started to look at how we could come up with an assembly that would require little to no training, like 30 minutes of training. And the same guys who work with sticks, we call them, someone who frames with wood, we call them a stick framer.
Okay.
So someone who builds houses out of sticks, a carpenter, could build this house, this high performance house, with almost no change to their system or their process.
Okay.
At the same time, make it more resilient, so way more durable, and dramatically more efficient. And then it figured if we could do that, and if we could do it with things that were readily available. So that was one of our rules. No special order parts from the other side of the world where you can't replace it or it becomes hard to source. So everything had to be stuff that you could get. And so that's what we came up with, was this total assembly. And we've built a few of them now, and some of our peers a number of other people have built with them as well. And they're just They're easy and they're high performance.
Okay, so forgive me, complete beginner, no idea, right? So I'm thinking, okay, I know you got to put insulation, so why can't you just put like a good amount of studs and some insulation? How is this different than my simple approach to it? I've built nothing, by the way. I just car stuff. I haven't even repaired. I've never even repaired a kitchen. Like I know nothing about houses. Okay.
I love the idea that out of this conversation that there could be shop teachers out there who instead of teaching them to build like little clocks, are actually gonna have their students building assemblies and then testing them out to see what they do. Because that
Don't even get me started. Don't even get me started. Everybody's story is, oh, I had shop class. Yeah, we made the napkin holder. No. Stop it. We got to do the thing is, it's so my definition of engineering, which needs to enter the space, is you got a baseline, and then you came up with something, some measurable benefit to the user. And that could be a computer program, that could be a robot, but we got to make some sort of improvement. Even if it's a napkin holder, maybe it's a lighter, stronger napkin holder, but we got to measure this stuff and we got to test it out. So I 100% agree with you.
So I'll use an analogy because they work, right? So we've got air. We've got two things we're gonna talk about with this one. One is going to be thermal control, and one is going to be air control. And we're going to use an example I call the naked carpenter, but we could call him the naked auto mechanic instead, or the naked shop teacher. And you take the naked shop teacher.
This is not a good image in my head. I had to say something.
I mean, I could pick on Nick or Duke here, but I feel like that would be unfair.
No, I had to say something. It's fine. Go ahead.
So you send them outside in the middle of winter without anything. They're going to die, right?
All right. Yep. Okay.
Yeah. So then we say, well, we're going to air seal. We're going to make them super airtight. We wrap them up in saran wrap. Give them a little straw so you can breathe. Set them outside. Still going to die.
Yeah.
Right. All right. That didn't work. So we get another one. This one we wrap them in. We get some big fleece, some good, a lot of fleece pants and some fleece jacket, and we set him outside. He lasts a little longer than the first two, but he still dies.
Yeah, he would definitely still die. I see. I like this because the naked cleared my head of zero material. Now we're going through the materials. I like this.
Yeah.
And we're going through failures. This is my favorite way to teach. Okay, please. This is great.
But with the fleece on, we're in the 70s, roughly. We're working our way to the 80s.
We're getting up there.
The time period. He's not talking about the temperature.
So now we pair the two. Now you put on a fleece jacket, and over that you put a windproof shell.
Now we're holding what we generate and keep. Now we're holding it because the fleece gives us some space to kind of to get hot, but like the air space, but then it doesn't blow away because we got this thing. I like this. This is cool.
Yeah. So we insulate and we air seal the two together. That's the secret sauce.
Insulate and air seal.
This is where the analogy doesn't work as well. If you think of your arm as the studs, as the wood of the wall.
Okay.
Right? We don't say, I wonder how I could shove insulation inside my skin before I go outside.
Right.
One of our building science guys, famous guy, Joe Stebrick, says, don't eat your sweater. You don't put the sweater on the inside. You put it on the outside. The insulation belongs outside of the structure.
Oh.
The air control belongs all the way on the outside.
Interesting.
The stud cavity should be empty. We want that to be warm because there's the third element, water. right? Humans produce water. Cooking produces water. That aquarium that your 15-year-old kid really wanted produces a lot of water in the form of vapor, right? So where does all that water that you're creating inside the house go? Well, it finds its way through cracks and holes and whatnot, and it gets into the wall cavity. And when it meets that cold surface, it condenses. So what we want to do is we want to heat the wall cavity so that but when air moves moisture or moisture gets to that exterior space, it's inside like a rigid foam, something where there is no airflow, something where it cannot condense. And if there is a bypass, if the brake's not intact, it condenses in something that is largely inert, something that just doesn't care if it gets wet.
This is very interesting to me. Okay, I think I understand. Can I assemble this back?
Yeah, do it.
All right. I'm loving this. This is fantastic. Okay, so you got the naked guy, right? Now he's gonna produce vapor because he's hot. He has stuff, just like if you sweat or something like that. And
He's breathing.
He's breathing. Perfect. If we do the Saran's wrap, we're gonna protect him from the wind, but he's still really cold because he feels it right up his skin. Then we're like, all right, let's do the flannel. Okay, great. He's a little warmer, but it blows away when the wind comes. So we use the flannel and the Saran wrap. Now we've blocked the wind and we can get warm. But the problem is now it's going to be hot inside. Humid, very humid inside. Very humid, and that's going to go slide down the wall, and it's going to make almost like if you go underneath your blankets and you thought it was going to be cold that night, but it turned out that you wake up like
You're sweaty. You turn into a prune, right?
Yeah, it's awful. Okay, so to maybe prevent some of this or reduce it, you actually put all of this insulation we just talked about, the air barrier and the flannel on the outside, and then that wall that it's up against is kind of warm.
Yep.
And that is not going to be the condenser the way that the soda can would be, or less so.
Less so.
And then you might put something on that which will be less affected by if you do have condensation.
Yes. Yeah.
Wow.
Yep. And that's where this is where the math kicks in. Where here's my wall. Here's the sheeting on my wall.
Okay.
It has a weatherproof or waterproof coating on it.
Mm-hmm.
Here's my insulation. Here's my cladding or my sheeting or my siding.
Uh-huh.
Where in the assembly will condensation occur? And that's a combination of understanding temperature differential, the pressures on the building, which accelerate. So if there's a greater temperature difference from inside to outside, it accelerates that energy loss through the assembly, which can accelerate that drive. But you got it. You totally nailed the general concept of the assembly. And that's why we all spend money on Gore-Tex, right? Because it's a vapor control layer. It does bulk water control. It sheds big water droplets.
Uh-huh.
But it allows water vapor very slowly to move through it. And that's the difference between wearing a rubber raincoat and sweating to death and wearing, some Arc'teryx Gore-Tex type shell.
Oh, it is night and day if you have some old ski equipment versus the newest ski equipment. I mean, I don't even think old ski equipment is as bad as the old ski equipment that I'm thinking of. I mean, you could have a glove that at the end of the day, it is like
wet.
Or you could have a glove that's dry the whole day, no matter what you do. And it is a massive difference.
Yeah. Well, I mean, we used to, you go back far enough and you realize that people who lived with the elements really had a good understanding of the physical properties of these things. And then we kind of forgot. And then the 80s happened and and then we're now. But you're spot on. The ski analogy works great. You're generating heat. Where is that heat going to go? Where is that, right? You need to find that balance in that assembly.
That's so interesting. Okay, can you just talk about the pressure thing for a second? So when you say pressure, is it actually PSI we're talking about, or is it movement, or what? How does that work?
So
am I not interpreting the word that you're used to the pressure?
Pressure. PSI is a fine way to describe it. I mean,
I'm like, you gotta realize how simple this is. I'm thinking tires, like.
Yeah. I mean, it's really not that different. We use a different metric, but it's all pressure. It is still pressure, and it's the pressure. I'm going to botch this one. Well, kind of like you were describing the compressor tank a little bit. When there is more energy in hot air.
Oh, because it's active. Sorry, I stepped on your line there. You basically more energy in hot air than cold air.
Right.
And
all right. And energy wants to find equilibrium. And so energy will always try to move from a place of more to a place of less. So if you pick up something cold and it feels cold, you lose energy from your body to that thing. You warm it up, right? And so that's this conductive transfer of energy through objects. Yeah.
Okay. Yeah.
And then we have so we have conductive loops or conductive transfer. We have convection loops, which is like air movement or water, right?
Mm-hmm.
And then we have radiation, right? The sun hitting surfaces and heating them up. And so wherever we have more energy, we're going to have something that has more energy is going to perform differently than something that has less energy. And if I put a membrane between the two things and I add input over here, it's going to flex, right? It's going to, right? I'm putting more into it. It's getting stronger and it wants to dump its energy over here. There's a thing in the way. Right. And so it's going to push against that thing until it wins. Because it will always win.
Yeah. What is an like a real example, like do you have an example of something breaking down like something would eventually disintegrate or allow passage of energy, or what would that be? Yeah.
Have you ever guys ever there's some really cool physics teachers out there who, if you Google YouTube, they'll show you like what happened. They'll take like they'll take a steel drum.
Oh yeah. Like the Mythbusters.
Right. And they will depressurize and then they'll add a little bit of heat and it goes like this and it just collapses this steel drum. Right?
Yes. I know.
So that's demonstrating that pressure change in a very extreme way.
Wow, that's amazing. It's unbelievable. I work in a public high school. No one mentions this building science, yet everybody's inside a building.
Go figure.
I had this kid. Yeah, go ahead.
No, I think building science would be a wonderful thing to teach in junior high school, middle school. I mean, it's practical application of physics and energy. It's like all of that stuff. What makes shop class cool, right, is that you could see a direct connection between what you were doing. You have this real understanding of friction You start to understand chemistry a little bit, right? There's all of these things that because you do it.
Application.
Yeah.
The application of all the physics that you took in class. They're all going to forget the memorized stuff, and then they come to our class and they actually do it. Yeah, I agree. That's cool. This is awesome. Yeah, that's a cool one. All right. I got some other questions here. We're not done with you.
Okay. Well, this isn't too wonky. I mean, I feel like we went in deep, and I'm trying to do. Yeah, you're good. Okay.
No, these guys, Duke, Nick, this is typical, right?
This is it.
Yes.
Yeah,
All
we're
right.
digging in as curious shop teachers, talking to people in the field and who are changing the industry. Want to talk to you people. If anyone's listening to this and you got something you want to tell the shop teachers, please get in contact. Yeah, this is it. No, I appreciate you taking the time to do this.
Michael, let me ask you this. My parents' house, a couple of the additions, the vapor barrier was put underneath the sheetrock, and then the studs and insulation and outside sheathing. Is that still common practice, or is it more wanting to go to the total exterior so you don't have that thermal bridging? Because using all of the analogies we've just been using, you're keeping your moisture in, and then your cold air is in that wall system, and it would condense on the inside. And, again, using the analogies, is it still a common practice, or?
So yeah, we're cold. We are in what we would describe as a cold climate.
Yeah.
And in cold climates, for a while, the building codes had us putting a vapor barrier in the walls, which was usually in the form of something like 5 mil poly, which was possibly the single stupidest and worst thing we could have done to our homes. The first mistake was calling it a vapor barrier, because it should have been a vapor control layer. And the second was using a vapor impermeable material that is nearly impossible to install properly. And this is the rub. Batt insulation, fiberglass batt insulation, is almost never installed properly. It is supposed to be fluffy, not compressed. It's supposed to, touch all 6 sides evenly. That's not how it gets installed. There are always gaps. It's always compressed. The electrician pushes his wires. The plumber rips some of it apart. And then the guys who hang the plastic, they bang a million staples into the thing. And they don't really believe the vapor barrier thing as well. So they put a couple holes in it for good measure, because house has got to breathe, which a house does not. House is not an animate, living object. It is inanimate. It has no need for respiration.
But I want to see my curtains move in the winter.
Yeah. So what we did was we drove hot, warm air into our walls where it came in contact with cold from the other side, condensed, and we had the mold of the 80s, 90s, all of the mold houses.
Mm-hmm.
So we've got these things now called smart vapor retarders that are supposed to do a better job at that. I think almost all the high performance builders I know, they either switched over to using a spray foam insulation because it is an air seal, so that air is unable to move through the material, and vapor is unable to diffuse through it either. So it's one way to solve the problem. But the vast majority are moving to 2 or more inches of insulation on the exterior. And when you do that in the building codes, you negate the need for a vapor retarder entirely. So in the Awesome Wall system, for example, we eliminate one of the layers. And every time you can eliminate something, you eliminate possibility of failure. And so the reason we have 2 inches of insulation on the outside is for that. So I'd like to say that I think that the trend is definitely heading that way. But the vast majority of production builders are not producing that.
Yeah.
And
Interesting.
big caveat, if you live in certain climates, it's just not important.
Mm-hmm.
Oh man.
Yeah.
Trouble showed up.
We got some late joiners to the party. Oh man, Matt Bloomquist, Willie's here. This is awesome. Thanks, guys.
Sorry for showing up late, Michael.
No worries. Glad you're here.
All good. Are those cassettes behind you?
I don't ask me where that came from. The only time I use Google Meet is on this. I had no idea. I think maybe Nick sent it to me.
We got
Thanks.
we got
Thanks
some
a lot.
good. We were talking about the 80s and 90s, so it's a good theme.
Perfect. I don't know what the heck these are, but if they were really that large in life, we probably would need a bigger car to pop them into when we drive around. Your ghetto blaster would be.
I think it's playing thermal break dancing music.
Hey, there you go, dude. Right on, bro.
That's terrible.
There's your soundbite, Rod. There's your soundbite.
Yeah, that was good.
It's funny. I gave a talk on that today, and thermal, right, for heat and cold transfer actually behaves very similar to sound. So when you mitigate one, you often mitigate the other. Pretty interesting.
Oh, that's interesting. Yeah, that makes sense.
Yep.
Huh.
It's a path of least resistance, right? There you go. There you go. Double break. It's a double break, Nick.
Nice.
So,
This is good.
I missed the whole presentation, Michael. I missed everything.
Well, we were just
Not everything.
I like the guitars better, man.
Yeah, thanks.
That's funny.
No, they're just started like putting the thumb screws in, started just tightening a little bit. They wanted to get into pressure differentials and delta T, and I was trying to back away slowly.
Got it. Well, the delta could be quite radical, right? If you live in San Diego, the delta of the inside and outside is blah.
That's a good way to phrase it. I like that. The delta of San Francisco is blah. The delta of Minneapolis is not.
Right.
Okay.
Right. Well, except for about 9 days a year, it's pretty.
There we
It's
go.
pretty okay.
I'll take that.
Okay.
Yeah.
The delta is the difference, right?
The difference. It's some people claim that it's a technological term and math is involved. It's not. It's actually written by the Romans, and it means a whale's vagina. I'm sorry, that's a Ron Burgundy riff. I can't own that one.
I feel like we need to put a Uncle Roger Sorry Kids in there.
No, that was an animal reference. It had nothing to
All
do
good.
with anything else. Strictly zoologically
It's a shop
speaking.
feature podcast, so we're PC, but we run the edge of the '90s edge right there.
That movie was PG, so it's okay.
Yeah. Speaking of thermal breaks, no, what we were doing was he was giving us analogies. Michael was nice enough to entertain my beginner brain when it comes to this, how you assemble the wall. I had no idea you put the insulation on the outside, or if you do, you'll have a nice result, reducing your condensation and whatnot. Something came up, Mark. Maybe you could help me with this one.
Probably not.
Yeah,
I like people to get challenged.
I was talking with someone about the T-stud. Okay, I'm gonna put you on the spot for a second. All right.
All right.
And I said to them, it's amazing. There's a thermal break, and it's structural, and you can use it. And she said, yeah, so it's just offset. Who cares? And I was like, whoa. I was like, okay. But what, isn't it still an advantage? It's assembled for you and it's structured. You'd have to make this thing, right?
Yeah, so her statement, I don't know her. So speaking out of context is always fun, right? Because you're going to be right every time.
Yeah.
So she said, "Is it what was her wording, Rod? It's just
It's just an
offset,
offset.
right?"
Yeah.
So, like when Michael was speaking earlier, I didn't hear what he said, but the insulation on the outside, right? So if this, assuming this lady has two hands and assuming she drinks beer, right? We're gonna put her favorite beer in her left hand, and she's gonna hold that bottle. Then we're gonna take a beer that she absolutely despises, and we're gonna put it in a koozie. We're gonna give it to her right hand. And then we're going to see, you can't drink any of the beer. Now, granted, we're in San Diego. It's 74 degrees, and that beer is starting to condense, right? I'm going to tell you, you can't drink until you answer a half hour of questions. At the end of that half hour, the beer she wants to drink tastes like the temperature of a horse bath, right? And the beer that she doesn't want to drink is cool as a cucumber. So your answer to her, Ron, would be, well, what's the difference in those beers? That they're just offset and the other one's not.
This is awesome.
Right?
I knew Willie could handle a random shot. Boom! Deflected.
Yep. It's not to say I'm right. It's just to say I was able to ignite an answer, right? It could be completely BS because that's what building science is.
Nice. That's awesome. Yeah, I like it. That's cool. Yeah. So I'm learning so much here. This is awesome. So
Classic MacGruber. Classic MacGruber.
Classic MacGruber. Gee.
What is that? What is that?
It's an SNL reference.
Oh.
Yeah, but he had a movie too.
Did he? Oh, he did a whole movie.
MacGruber was a movie. I guarantee you can't chew M&Ms or Doritos without spitting them out your nose. It's that funny.
Oh, all right. MacGruber?
Oh yeah. Oh my gosh. And yeah, you know, well, we all were around for the good SNL days, right?
Oh yeah.
But
come on.
that MacGruber, if you could take a sketch and turning into a movie, you're not doing half bad, right? None of us have done it yet.
That's awesome. Yeah, I'm looking for some good comedy lately, you know? It's not the same. I tried watching SNL lately.
Yeah. Even the musical guests are like, that's music, right?
Yeah.
Oh, ouch.
Oh. Yeah.
I don't know. I thought that the clown sketch the other day was pretty good. That was pretty cool.
It's been such. I don't think I've hit that show in 2 years now. And I used to to me that was Saturday night, right? That was everything.
Oh yeah.
Yeah, that was awesome. All right, we were gonna dive in. But I wanted to ask Michael kind of how he got into this industry, because I know he kind of did a little bit of a zigzag and a whoop-de-doo and a loop-de-loop is what I meant to say. And he traveled, which was awesome. But before we get to that, I was going to ask, since Matt's here, Matt, you want to give us an update on the house build?
Yeah, I don't have as much to talk about as I did like last week.
Okay.
But we
well, let me just introduce you a little bit. Let me just let people know, Matt's in a situation where he teaches shop class, but it's literally, this is his classroom. And they're building a house. And that's what they do every single year. They get a piece of land, build a house. Kids are out there building a house with them, which is, that's the whole idea. And here they are, oh, cool. We got a little video. Oh, they're learning.
Fast Master stopped by. It's been a while ago now, over a month. Obviously, the kids are in shorts, so.
Yeah. That's cool. Okay.
We got Rockwool here Monday.
Oh, really?
Dan Edelman's coming by from Rockwool.
That's cool.
So they're doing eating some ice cream. Our girls won sectional, so we're going to state. So I'm all still kind of jittered up right now.
Oh, your kids. Yeah. Okay, no problem.
Yeah, my third oldest stepdaughter. So anyways, yeah. So pretty much we got the roof sheeted. We don't have the hips and the top vent covered up. So today it rained this morning, so a little bit of water is coming in right there. But I mean, I'm gonna say 99% of our water is shedding, so it worked out great. We were working inside. We were putting the our, I call them attic baffles. It's the ventilation for our vented soffit, so that way the air shoots up the underside of the roof sheeting and up towards our ridge vent. Because above your insulation.
Are those baffles foam?
No, so we had the Energy Hill put on the trusses this time,
Right.
so it was taller. Now last house we had that low pitch roof, and when I told them I wanted like 12-inch heel, well, I didn't catch that. That was 12 from the bottom cord to the top of the slope. So to me, that was an 8-inch. So what we had to do was to get a little extra insulation in there. We did use rigid foam there, but this time, I mean, we're good and tall, and we got a steeper roof, a 612 pitch, so we got a lot more area there. So all we do is I took this out of Mike Gurton's playbook from Fine Home Building. Instead of using those cheap, I don't know, foam, baffles that they don't span the whole distance. I mean, I don't know. I've never been a big fan. Plus, when you staple them in there, you bust them up. They get trashed before they even become useful, I think. So we cap the end of our truss. I don't have a picture of this. I'll talk about it this week on Instagram. I'll do an update on it. But we cap the end of the truss with leftover zip bar sheeting. Since that's above our air barrier anyway, we use our drywall as our air barrier.
Right here, Matt, is this a good photo or
okay?
No?
Yeah, there's a good picture. Yeah, kind of. Yeah. So where this is at, it's over the porch, so that's why you don't see a rafter tail right there. But anyways, right above that, what we did was we capped that. We sheeted up above that, and you can see the black zip tape rolled over the top because that's connecting. That helps connect to our air barrier going across our ceiling. But at the end of these, going up the rafter tail, so going up the slope, we just tack little 1x2s up. So you got 1.5 inch runner, and we set it on top of the sheeting and run it up, and then we touch the top of the sheeting underneath side of the roof. So it goes, from 3.5 down to 1.5 inches. But it's a whole approximately, 22 in change width. So that whole vent is wide open, and then it works out pretty good. I mean, we do have a hip, it's hipped all the way around. So the bottom hips are kind of a pain in the butt, and I don't know. I mean, it works, but you don't get the ventilation you really want there.
I want you to pause for a second, Matt. When Ron, when he says the baffle in that area, does that make sense or is that baffling?
Mark, I'm glad you're here because I have no idea what he's talking about.
All right. So
when I'm thinking baffle, I'm thinking inside the gas tank of an engine to stop the sloshing from happening, or a rocket ship, which, by the way, there's a great SpaceX story about the baffles breaking, and they had to fix it in an airplane while it was flying to its destination. But as a house, what's a baffle? No idea.
For me, I say baffle. Some people may say shoot, but pretty much if the air's coming up, your overhang, the soffit, right? The overhang of a house, it's vented. The air's coming up, and it's going up this way and up towards the ridge of your house. So this one I would call the baffle, the sheet. And then we put little runners there. We attach on it. We just use Luan because at $20 a sheet, it's the cheapest plywood OSB sheeting good you can get. Holy hell. It used to be like what, $9, $8 a sheet. So, but it's just 1/4 inch plywood, cheap, not inexpensive anymore. But the kids just shoot it on with a crown stapler. We put a little spray foam above where it connects just so there's no wind blowing through, because when we'll have blowing in cellulose, you don't want to get any wind washing in there and blowing your cellulose around and stuff. And I mean, we just cut 4 foot, the length of the plywood, 4 foot lengths, whatever width, and the kids got a couple kids on the track saw cutting, a couple kids up there stapling, and goes pretty good. And Yeah, so that's what they've been working on. We were inside. We were working on framing the opening for our crawl space hatch because we have that special hybrid foundation that Steve Basic and Jake Bruton did. We just and Steve provided the plans for us, and Halo just our shipment of Subterra 2-inch insulation. That's actually graphite. What is it, guys?
Yeah, it's basically a graphite neopor, right? Based. Is it neopor? I'm gonna butcher that.
I get all those. I
get
all those science words. Maybe Michael. Is it X or is it? Do they usually use EPS? Anyways, we're using it underneath.
Usually expanded polystyrene, but
yes.
Yeah, I think well, Halo is licensed under BASF, so I think that's right. Their trade name is Neopor, because I was confused. I almost said neoprene, so I was correct. But it is some of that. It's their superior product.
And we got
it's expanded. I just looked it up on BASF. It's expanded polystyrene.
Yeah, EPS still. Yeah, the graphite. Yeah.
So, but we got the 25, so that means it's 25 pounds per inch, 25 pounds per inch for the pressure. So that, because what we're going to do is we're going to put it underneath our subfloor, which will have a double layer subfloor, and Steve Basic walks on it with his 180-pound frame, right? So it works for him, as he always says. It's going to work for us. So if Steve ever watches this, yeah, he'll laugh. But yeah, I mean, it worked out great for those guys. I've actually walked on that floor when Jake and those guys did it. Halo, thank you to them for helping us out in that situation with that. So, and like I said, Rockwell's coming. Dan's coming from Rockwell. We're gonna line the inside of the crawl space walls. That'll go up, and then that Halo will come and connect to that. And we got Rockwell down the side of around the perimeter of the concrete and down along the bottom. So there's our continuous insulation going around there that will connect into the walls. Our air barrier we put onto the outside with the zip bar panel. So there's our exterior insulation outside of the T-studs. So it should be a pretty good wall assembly. I think we may have some special guests again when it comes time to do our first blower door test. And this time we may actually get to do the blower door test before we get the windows in, which I'm kind of excited about, just so we can do one before the windows go in and one after the windows go in, just so the kids can see whether they did good, bad, or indifferent. And then, of course, we'll use the blower door and thermal imaging camera to go hunt down all our air leaks. But, yeah, the kids are doing good. We're getting to the point where I'm happy now. We're not all just working on the same thing. I got kids scheduled doing this, that, and whatever. And they now have enough of the basic skills where I can be like, okay, you guys go get those measurements, go get those cut, tell that group to cut for you. I'll go show these guys what we got to do for the door hatch, which we have to air seal treat, just like, because our crawl space is technically inside of our house. It's inside of our envelope, thermal and air. And yeah, so we're a big green box with a red roof, and Owens Corning just signed up to pitch in on the some of the costs for the shingles. So we'll be putting on traditional asphalt fake shake shingles and stuff, which is pretty common around here and easy for us to get. So now the kids won't do all the shingling. If the crew's here shingling, we do sub that out, but they can go up and help. I'll send a couple to help. I'm not putting 15 kids on the roof for obvious reasons, and then even if they're strapped in, all that is a rat nest mess. So, but if there's
you're really good. You could probably knock it out in a day, couldn't you, Matt?
Man, 20 years ago. It's been a while since I ran the shingles now. So, you know what? I probably could, but I'd have to take a week off to let my back catch back up. But no, it's going good. Like I said, as of right now, to show progress from what we've done doesn't look like a lot, but we've hit that major.
Oh, are you kidding? To me, it's amazing. Oh,
Yeah,
sorry,
yeah.
Matt. Go ahead.
I mean, from the last week and stuff, but yeah, we're shedding water. That's a big deal. And so, technically we can start roughing in some wiring if we need to. Holes already drilled. We're using T-stud, so don't have to make any more mess. But yeah, we're excited for Dan to be here next week, and we'll do some fun things with them and Rockwool, and kudos to them again for helping out on the build. And yeah, I think that's about it.
Matt, are you racing against the snow yet?
Not yet. Today it rained. It was raining this morning, but it was 60 by the afternoon. So I think tomorrow's supposed. We have a day almost getting to 70, and then it'll drop back down to 30. So it's Midwest.
I was telling these guys earlier. One of the kids I taught, I saw his dad outside of school, and he's going to our local community college for construction. And I was like, back before I started this podcast, I think construction the same way it was for the past 100 years. But I told him, I said, no, there's a group of guys on here building sciences. It blows my mind. Stick with it. They're doing awesome stuff. So
yeah, and I tell everybody, man, I'm still so much a student. I mean, like what Michael and these guys know, and good thing is people like Michael and Jake and Steve and Mark and all you guys that are connected, putting stuff out there. You make my job way easier.
Yeah, and as you're talking, Matt, I was thinking, you've been through in this school district for a couple years, right? From when I'm
on my fifth year, yeah.
Fifth year, yeah. And you said you know the teachers that came before you. Do you ever look back at some of the houses, or do you ever drive by some of the houses that you originally built, and then you look to where you are now?
Yeah, some friends of ours live in the first one that's just down the street. It's small and stuff. They're remodeling their bathroom and wanted some advice. It's held up and everything, but it was finally the bathroom was bolted out pretty bad, and because I think insulation had been added up into the attic, and so like Michael's was talking about, you start losing your drying out potential, and you start fixing things, and then you create more problems. All the building science people tell you, you do this and you create 3 more problems you got to fix. But which is something I'm definitely learning, and yeah, it's nice to have people that can just text and message and give me the answers, and then I have to make my students work for the answers before I can just.
But it's also an awesome
teachers get special privileges. But no, I've learned a ton. And then I see stuff in my own house. I'm like, God dang it! You don't want to tear it down and rebuild because that's bad. But at the same time, you just want to tear it down and rebuild. Right?
I see these.
Michael's remodeled enough.
It's true.
Duke, I'm right with you. I'm watching Matt build this house and improve, and how excited he is working with all these pros that are cutting edge. And I'm looking at my cinder blocks, and I'm like, wow, this is like I think we could step up from here. This is basically a carriage house I'm renting. This thing's over 100 years old, and like Nick said, the curtains move in the winter. It is like it just right through. I'm paying the heat bill. That's why the landlord doesn't do anything about it, But I'm gonna, I'm in a position, and I really don't want to buy someone else's problem. I think I'm inspired. I want to look at the new techniques and maybe go from scratch. It looks cool, I might have to drive a little bigger commute because I live in a dense neighborhood, and there's nothing available as far as land. But we'll see. I don't know. Maybe it'll be a ski house, and then I'll get an apartment close by here,
There you go.
Yeah.
So
Nice.
what is it about the halo and the graphite that makes that EPS better than regular EPS?
Mike or Mark, you may know better, but I think on the environmental side is one of the big things, right?
Yeah, they claim, Nick, that EPS is the lowest embodied carbon of any foam if you compare it to a polyiso or an XPS. So it's basically just a larger area for more air, right? And then the supposedly BASF's formula right? Because they make great cassettes behind me. Their formula is like they have, in terms of the ratings and what they achieve of the value and the lifespan and everything, it's supposed to be the best out there of any product. And so that's why theirs is shown. There's 3 or 4 different categories, and with facers and without facers, for grade, for wall, below. It has that versatility. So Halo licenses that from BASF, and I believe 2 other companies do as well. Very small production when you compare it to like Dow, Blue Board, or XPS, Owens Corning, Pink Board. Those folks pretty much have that, the run in the mill, but they all buy certain components from one another. It's a very incestuous market. And as we know, Texas is where one of the main components come from that foam, right? So they make that foam in Texas, but they don't use that foam to protect the building from freezing, ironically. So,
Yeah.
Now, with the graphite in it, are they able to manufacture it into like SIPs panels as well, or is it just not cost prohibitive because of the cost difference?
Michael might know that the only SIP type thing that I've seen using a graphite EPS, which I think they call it a GPS, which is not exactly right, but right, is Wally Walls. And they use steel studs. So they're located in Wisconsin. David Wallach, happy to introduce you if you want a really smart developer at some point, who's also a manufacturer, who's also a lawyer. That's the only person that I've seen. But there might be a SIP, right? There might be. Typically, the SIPs just use EPS because at that point, what's the benefit of the graphite?
Mm-hmm.
I mean, yeah, I would agree with that. The graphite offers a slightly higher long-term R value, so the degradation is supposed to be less. It's slightly less conductive, so it holds its R5. Dow DuPont is producing a new 0 GWP version of XPS, and it's gray to look like the graphite. But I would argue that in a SIPS home, having the additional bump that you might get of half an R is largely irrelevant. And it would just be a matter for the SIP manufacturer of which EPS producer they're buying from to laminate their OSB to.
Yep.
That's exactly right, because the SIP, I think, when you look at it, already has the OSB or the plywood. That is doing so much to encapsulate the EPS. But these other folks like Wally Walls or Halo or the 2 other people through BASF, that is more exposed, and it's more exposed in the transit and everything else. So that's why you'll see the facers and all that one of the reasons you see the facers is to protect it, but it also makes the production possible. Just like gypsum, why is that paper on there? Well, we need to paint it, but it also makes the slurry and that formulation a place to bond and mat to.
Interesting. The EPS, the expanded polystyrene, is that just foam? Is that what we're talking about? Or
Yeah, just styrofoam cup.
All
large scale.
You might say, Ron, it's expanded polystyrene.
Yeah.
Oh, it's styrene. What did I say?
There's foam on your Guinness. That's foam.
Yeah.
Okay.
It's all foam.
That's funny.
You've got EPS, XPS, polyiso, foam glass. Then you've got your spray polyurethane foams.
Yeah.
They're all foams. They're all some sort of a polyol with a blowing agent that forces air into this thing that then cures encapsulating the air, and the air is the insulator. So the material, the plastic material, whatever it is back to the balloon analogy. It's a billion little balloons, right? And so but the air is actually the insulating component in there.
Oh, that makes sense. It's kind of like, in a way, like we talked about with the Gore-Tex jacket type of thing, but smaller and lots of them.
Yeah, or it's a bubble bath.
Yeah, there you go.
What was that?
Bubble bath.
Oh,
That's foam.
Yeah.
oh yeah, that's well put. That's really well put.
It's using an oil-based,
Is it a bubble
membrane.
bath? I'm not sure.
Yeah.
It's not very stable. It's easy to pop, but that
serious analogy consideration look. I don't blame you. That's good.
Well, the other analogy that it led me to is the encapsulation of air, right? So it's there. The resistance of the bubble bath is not quite the same resistance of a polyolefin or a Wonder petrol product.
So funny. Okay.
The better question for Nick, the better question would be, what's the ignitability of each of these?
Well, that was the thing. I had taken a class with, I don't know if you've ever heard of
Nick's
SIP
a fireman. Nick's a fireman, so this is a consideration. Nice, Willie.
What's his name? Cobb. Rob? Bob? Cobb? It's a SIP school in West Virginia or Virginia. I went to it, and he's a dealer for one of the EPS SIPs panels. So, he did a hot ball test where he takes a 1-inch ball bearing and drops it through to make his electric chases. And, he took a torch and just lit the foam, and it didn't, just ignite because they put the inhibitors in it and everything. At one point I was all about SIPs, but, then I was looking at, I think, Murris panels up in New Hampshire. They're polyurethane with like dogs that interlock to the next panel with like a keyway or an Allen key or whatever. So I was able to get panels from him from the class, and I put one of the weed torches right on it, and the OSB lit off, but it didn't just burn the whole panel, even with the torch. So I understand the science behind it, the EPS and everything that way, but I just look at the chemical end of it. Once the structure does start to burn, all that black smoke, and I know in any of our structures it's going to happen, with all the materials that we are using now.
That's the theory, right? Is at what point does it ignite, and is that enough time to get the people out? The building might be toast, but the survivor rate
goes down real quick. That's the one. We've had a couple structure fires here that I mean, it was one of my students, and I didn't know it at the time. When we're on a scene, you just don't know. And the whole first floor collapsed before, just the floor structure, not the upper floors. The whole first floor collapsed before the fire trucks even got there, because it was all I-joists. And I totally understand, building science end of it, ease of installation and cost and everything, but I still want to use 2x material for any structural. But
so this raises a really, really, really good point, Nick. I think there are different camps. There's the energy guys. They're chasing energy at the expense of all it. Right? You add insulation to a building, now you've got moisture issues, right? You've got the folks who are chasing materials at the expense of energy. And what I really like are I like Living Building Challenge is one of my favorite programs out there. I helped write a program called Green Star, which is run out of Michigan. And trying to take this larger picture approach to the right material for the right location and the balance between all of these things. Most people, load their house up with carpet, right? Well, that's plastics. When they burn, that's pretty nasty stuff. Corian countertops, LDF or MDF, formaldehyde, mattresses, bromated materials. But I'm not concerned about the spray foam behind the drywall and the OSB. It's the stuff that we load up our buildings with that's unhealthy. That's the stuff that when it burns is super nasty, but it's just generally nasty to live around it. But then there's this other piece. We use 2x material, we use I-joist, we use LVL, we use steel. Steel is great until it's not. When steel fails, it fails catastrophically. Wood is much more likely to weather a good degree of charring and burning and still maintain some kind of integrity. I don't think it's the I-joist that's the issue. The issue is, did the builder put in their fire blocking? Did the builder make sure to seal penetrations? Did they go through the steps to ensure that the structure was resilient and well designed? Or did they make a bunch of shortcuts and, have a bunch of mechanical guys, auger through half of their stuff, and they never sealed it up so the fire had a pathway to get there in the first place?
Well, the fire had started in the basement. So that's where, and I was just looking at a retiree from my school. His 1790s Colonial had a lightning strike, so it blew out the electric panel, and it then caught everything else. And he wanted me to replace some floor joists, and they were full 2x10s, and one of them was 80% gone, and then the next one right next to it is probably 50 or 40% gone. Like, it was just down that one set of bays, and it burned the others, but it didn't burn all the way through, and nothing collapsed. So, like,
that was a 1790 home.
Yeah, and that was the thing.
I'm sure it had cribbing. I'm sure there was cribbing in there as well. I mean, all kinds of other things.
Yeah, he had a vaulted hearth for the cook stove that was in the kitchen at one point, right above the electric panel, and that never actually collapsed either. But, like you said, and they did actually, because it was built by one of the millionaires at the time, there was block that went right up to the subfloor in between the floor joists. So the fire never actually went to the back half of the house behind the electric panel.
It never made it through the asbestos, huh?
Yeah.
So, Nick, you want to know the technical term for that? It's called, we call it beam fill.
Okay.
And the reason that they packed the concrete in there was to keep the joist from racking.
Oh, okay.
They didn't want them to twist because they didn't put down a proper sill plate back then. They didn't put a capillary break in back then.
It was probably green too.
It helped hold those joists straight. The other thing that it did, though, is it provided wonderful wicking for all of the moisture in the foundation. So we see a lot of these same ones, and there's a beautiful line of dry rot about half an inch proud of the beam fill where they packed it full of concrete.
Mm-hmm.
Sometimes the joist is completely gone in those spaces, and it's just kind of resting on rotted debris.
I'm in awe. I love this conversation. I'm just like, I like talking about, the best way I learn is through failure. So I listen to these failures. Nick is a fireman. He's talking about these failures, and you're like, well, let's talk about how that happened. And I'm like, yeah, how did that happen? That's amazing. I mean, this is all to the point that building science really needs to be encouraged in schools, because the wannabe fireman, not wannabe in a bad way, but the aspiring fireman could take a building science class in the wood shop and build a house. And I mean, you could take it out to the yard and light it on fire, see what happens to it. Or you could look at the thermal situation with it. And then the physicists, physics class could take the same thing, deal with the thermals and the sound editing. You could even make a podcast booth that has sound editing that could involve the video, audio and visual classes, or even the music classes and the band classes. So building science is everywhere. I mean, what a great topic.
Well, it's not everywhere. It's in Taylorville. It's not quite everywhere.
Yeah. I mean, is there any other, actually, Matt, is there any other teacher that does what you do where you actually build a house from scratch every single year?
Yeah, I'm starting to find a few. There's one that I met when I was over in Kansas City, and he's really follows along with the building science thing, and he's trying to get more and more of that stuff incorporated. But there's the stigma of it's expensive, and not really. I mean, right, Mike? I mean, it's especially now there's some
few and far between.
I'll say that again, Mike.
Just that they're scattered. We have one school that does it here, but they're way too few.
Yeah. Oh, absolutely. Yeah. And I mean, and me and Connor, which we all know Connor on here, and he's up in, Canada, and we've talked about, trying to find more and more, even what he does. And he's in the classroom, where a lot of his building science stuff, he's unfortunately just stuck in the class. Well, actually right now he's stuck doing it all remote still, but, yeah, they said, they told him plan on maybe even next fall. We're still remote. Yeah, crazy. But they're the house building ones, and then and we all know as teachers, you're dealing with schools who are all about the dollar, even though they swear when they talk to you, this isn't a business. The hell, it's not a business. Like it is. It's a money thing. It's all money. Otherwise, every answer we asked would be yes. So let's face it. But to find the ones that are not only still building houses, but the ones who are implementing, these building practices, and it narrows it down. Even I'm not going to say I'm the only one doing it, but makes me even, my situation or my program even rarer as far as the content. But once you start seeing what we're doing, when I was talking to Emily Montrum, I did a podcast, and we kind of came back and recapped about the last house and what I learned to what I'm going to do different and this and that. And like I told her, they have this concept, the pretty good house concept. And once you see that, and once I built the house, not knowing at the time, and then learning what pretty good house was, and pretty much falling pretty close in line to what their principles and ideas are. Really, this is the baseline. Like this should be the bottom. Everything else should be above. Passive house, the one you just said, Mike. The what was it?
Living building challenge.
Yes, living building challenge.
Living building.
Yeah. So the pretty good house idea is right here, and really, from what I understand, I don't know the codes forward and backwards, but as far as the energy codes, the newest ones, we're pretty much getting just about to the passive level, right? Is that right, Mike and Mark? You guys, I've heard people say we're getting close. No. I don't know it that well.
Pretty good house. Depends on your state, really. Every state is different. We all have different energy codes.
Yeah, and for us, I mean, you can go do whatever, and you didn't get permit for that. Oh yeah, I'm sorry. Okay, well, pay your taxes now. So nobody's. So we're kind of. Small rural Midwest, so we can do whatever the hell you want, right? So, but that was my thing. Since I knew we could do whatever we wanted, when the school said, "Hey, Matt, we're going to start building houses again," I said, "Okay." And I had been kind of paying attention forever, just follow along in the Fine Home Building, magazine. Air sealing details have always been talked about for a while, and so I was like, "All right, and when I taught at the prison, we had a small sustainability section. It's what they call it, sustainability. So. I was already kind of getting into things, and, I don't know, to me, like I said, I'm all about the, saving the planet side of all this stuff. But like, for me, I just think it's cool that you could potentially build a house that obviously is healthy, safe, comfortable to live in, but provides your own energy, charges your own car. Like, I just think that's cool. So like building, to me, it's just building better. And that's what we should all be doing anyway, right? So it's, for me, it was never really the benefits all come with less energy, use, and now more I learn and understand. Hey, buddy, that's a banana here.
It's a gun.
Oh, it's a gun. Okay. I don't know. It's like I told him, I said, this is just what we should be doing. Like, just because it's better, like we all know it's better. No matter what you think, political views, environmental views, it's better to build this way. It's been proven. Science has proven it. My kids, my students in high school have learned, they understand condensation and stuff, and because they're in these classes right now. So really teaching high school kids some of this stuff isn't that far a stretch, because they're like, oh yeah, I looked at that in science last year, a couple of years ago. All right. Or, just like same with math, talking about Pythagorean theorem. We had to relearn it because we hadn't used it forever when we get back into, building and stuff. Well, they're just like, I'm talking about 3, 4, 5. They're like, oh, Pythagorean theory. And like, yeah. Everybody thinks as adults, because a lot of times we haven't used that stuff. So it's foreign to us again, right? It's out of our mind. Well, these kids, it's all fresh. And so my big thing is now, and I think Ron kind of touched on it. Shop class is every class. Like, pick a class topic, and I'll find a way how we do it in shop class and stuff. And Brian, when he came down from Brian Iverson from TSA, when he came down, he talked to the kids, and he's talking about how he hates politics. So he goes, I need to understand politics and what I do, because I need to know what's going on in China and Russia when I'm making patents for products and this and so. Now you got politics. Well, you can go politics in the building all day long, but science, math, English, writing up business reports. I was just talking to Smartsheet. We're trying to incorporate business management into the next semester, kind of dabble it in. And I wanted to have a platform for project management and stuff. And Smartsheet actually has educators and students can have it for free. I was like, yes. So I called the sales guy, got a hold of me, and he's like, his name was Joe. He's like, Matt, I got some good news for you. And I was like, oh, awesome. Thinking, no, they're going to help us out. And he's like, you can already do this. I was like, even better. So,
Matt, I got to add on that. I just got to add. Oh, I just want to add to that, Matt, that it's not about saving the planet at all. Planet could give a shit. Planet, like the planet is a rock with us on it. All of this is about us and creating we have an ecosystem that supports our life, and that is a fragile little thing that hasn't existed on this particular rock for for much of its history. It's got a tiny little window, and our goal is to stretch that window out as long as we can. So if we should be building the best possible structures to support humans so that they thrive and have the best possible lives, and in turn extend this chunk of this window we have to live on this planet. That there doesn't need to be anything about saving any other species other than ourselves. Well, we rely on other species' existence in order, for us to be healthy and exist.
Yeah, well, it's Ben Bogey always says, "Be good stewards of the land." Right? It's just do the right. It's just do the right thing. Like, right? It's just like, I don't know. Why wouldn't you just build the best? Right? Why wouldn't you build the best car? Why wouldn't you build? It's just, yeah, I know. Yeah, right. We can all.
I'm with you guys.
For me, that's what it's about. And for the kids, I hope they see that. And what sucks is then I have my kids go off and work for other people, and on zip tape, you got to roll the tape. It's pressure sensitive, right? And they're like, I'm like, oh, but roll that tape. And they're like, they won't even give us the rollers. The developer won't give them the rollers to waste the time to roll the tape. They said, just hit it with your hammer and waffle head. I'm like,
what?
I told my student, I said, hey, you know what? I said, say you should roll it. They won't give it to you. You're not the one getting sued, man. That sucks. But, these kids are 20 years old and they understand how this product works and why it should work. And then you got this person who flies around in this helicopter to make sure the condo buildings are going up quickly, and wouldn't even, they don't even give the rollers to roll the zip tape per manufacturer warranty.
So that's like telling a plumber that they don't need the primer. Just all you need is one can on the PVC, right? You don't need the primer first, right?
Yeah.
So if you're not following the directions, it's fine if you know how to build a cabin, right? But for everyone else that doesn't know how to build a cabin, follow the darn directions, because it's not art, it's science.
It's like
Yo.
the baffles on my tailpipes. You don't need them either. I bought my first motorcycle, took the baffles out, hung them up, but then I could never get it inspected.
Well, there's a different rule of thumb there, right?
Yeah.
But
Speaking of
Matt,
that,
Matt
Duke
was
or Rod, do you remember that cord we used to have where we could dump it before it gets to the muffler?
Oh,
Remember that?
Lakes side pipes, Lakester.
It was awesome, and we didn't have the inspections before that, but I had an El Camino, and that was great. It was unbelievable.
That's awesome. I was just looking. I don't remember whose video. They had a solenoid switch, and it'll open it up and dump it out the side. Yeah, and then you know, but
This was a cable in the floor that you just went like that you pulled it through. It was redneck genius.
You know, I want to add one more point to this. Why should we teach the kids, and what are they going to do with it when they're up against resistance to this? Like Matt was saying, we teach them the right way to do it, and we prove that this is the right way to do it, but then they're up against it in tradition or industry. There's another piece to the puzzle, which I think is overlooked, which is that if you have a student who understands trends and technology, that person can make a really good investment with their money. And so this is what I mean. Imagine if you were taught about how computers work in the 70s or 80s, and then when the Apple computer came out, you understood the significance of it. Maybe you couldn't apply it in your life, but then when you went, like I worked pumping gas, and I worked for my dad at the bakery, and I remember I had $1,200 for the first time in my life, and it only took a month or two to make it. I was like, oh my God, all I did was work. I was making minimum wage, but at two places. It's all I did, pump gas and work at the bakery. And then I had this money, but I had no idea what to do with it, right? But had I put that money on Apple stock, are you kidding me? I think it's like maybe 30 or 40 or 100x. So the thing about it is that these students that are exposed to, let's say, Matt's building science, they might not be able to implement it because you're giving them something that's so ahead, maybe not ahead for the tech, but ahead for the traditions of the industry. But they at least understand what they're looking at. So, for instance, with my situation, where we built an electric car back in 2008, 2009, and Tesla had not even hit the stock market. But then when it did, one of my students bought the stock, and it went up, and they paid for college with the first time Tesla stock 10x. Then he sold it and bought me lunch to thank me. And then I went out and bought Tesla stock and watched it 10x again. So it's like, it's unbelievable. You know, of course there's the can I get a job in this industry, and or can I study it, and the things you think about, traditional stuff. But there's also, what does your money do to earn its own money, and how can you help the future? How do you fund the future? You can invest in the future. You can invest in, let's say, Rockwall is a traded stock, or let's say this, I don't know, this tape thing you're talking about. Maybe that's a traded stock, and you know more about it than the average Joe because you used it in your classroom. It's just another element.
You raise a really good, what you got me thinking is you were talking about the way that the industry has changed and evolved over the, I've been at this for 27 years. It is nothing like it was when I started. And I feel like I'm slowly becoming the old codger in the battlefield. And there are young guys who are showing up who are way more tech savvy than we are. And we're fairly organized. The days of the trades of construction being a bunch of libertarians out, building stuff and being just independent that is gone. They're still out there, but they are short for this world. In the last week, I saw 3 major remodeling companies be purchased by one company. And they paid over $100 million for each of the 3 companies.
Wow.
So one company spent upwards of $450 million to acquire 3 remodeling companies. Think of the level of sophistication, that those 3 companies were already operating at, to be valued at that level. For this company to say, I'm going to acquire these, and what kind of systems and process and standardization comes down the pipeline. And it's not just this one, it's happening all over. And this movement into the building sector by more sophisticated organizations, I think, is going to increase. And what they want, the people they want to hire, are people who understand building science, who are tech savvy, who understand components. They're not interested in guys who want to swing a hammer. They're interested in guys who know how to operate a pneumatic tool and operate it in a very particular way. So I think, to that point exactly, this next generation that's coming online, that is already so much more fluent in what would I say? I'll say I hate using big gross words like tech, but all of the tech that surrounds us and their ability to adapt and be fluid, along with understanding that buildings are complicated structures and understanding the componentry, makes them highly valued assets for a world that is changing, right? The commercial construction world operates very differently from the residential construction world. The residential world is going to start to look more like the commercial construction world, and the commercial construction world will continue to improve. More automation, more technicians running. This is what we're going to be doing, and the U.S. is part of that, but China is a huge part of that as well.
The U.S. Wow, there's so many important things you just said there. Like the one part, first and foremost, the group that bought the $300 million things, that's phenomenal. So an intrinsic question to that is, if they did that, does that entity then hire people that are from a work ethic and a deliverable ethic, or does that require them to say, sorry, you don't have a degree, you don't meet this criteria? So I'm wondering what that metamorphosis does to. So the pointed side of that, Michael, is a tradesperson, if given something, will want to deliver something that they put their thumb on. In most cases, it's unique to construction that I touched it, I left it better, I'm good. But if the deliverable then changes to a mechanism approach and a relay of, you have this job because you meet a criteria, well, that criteria doesn't have a teaching moment of, I made it as good as I know possible.
That's possible. I would maybe argue that I know one of the companies that was purchased. I know the owner marginally well. They have a training program when they hire people. They have very, very beautiful systems in which they navigate the clients, but also which their employees run. I think this company looked at what they had built and said, this system in here brings workforce in, trains and develops workforce, instills pride, et cetera, et cetera, et cetera. And we've seen this progression in other industries as well. And it ultimately leads to higher professionalism, which I think is also greater job satisfaction, along with that greater health and safety. I mean, there's there's so many benefits. I think for some of us, that's my thumbprint, that's my mark is important. I think we tend to be either entrepreneurial or on the innovation side. I think that there's a lot of people who want to go to a job where they feel loved, respected, and cared about, and their purpose in life is not their job. The purpose in life is their children or their family or their hobby.
Yeah.
But maybe,
No, this is really interesting. I'm seeing something similar happen in the car industry. If you, let's say you work for Tesla, well, it's not just turning wrenches. You might be doing data acquisition and analysis on a fleet of vehicles. They're trying to anticipate problems with a car before it even enters the dealership. You can go from working at the dealership to being a R&D specialist at the corporate level because the dealership is owned by the corporation. So there's students of mine. I have a student that got a job at the dealership. He's in it. He went to school for engineering, but I said, listen, this will get you in the door. He got in the door, no ego, got in the door, fixing broken Teslas. But that led to, a high level of research because it's basically an R&D place. It's not really just a repair shop. And then that led him to putting out fires in other Tesla dealerships, which got him noticed. So they flew him around the country to fix other Teslas. And then that led to now he works on the research and development of their prototypes to production. So he's working on the Cybertruck and the semi-truck.
This is a student of yours?
Yeah. And we started by just playing around. We were building like a Lotus 7, which is like, if you're into cars, this is the old Lotus, right? And it's a hand-built car basically, but with an electric motor. And, and because he's taking the approach of like a systems approach, a results approach, an efficiency approach, and a data approach, rather than, like you said, it's not just swinging hammers. And the old adage, this is the old thing that everybody says when I say, hey, how you doing? I'm a shop teacher. They say, well, that's great because not everybody's going to college. And I'm like, yeah. And if you go to college, you might have to use these to make prototypes. Like, you know what I mean? Or build a robot that does surgery or something like that. You're going to use these and this. And MIT is at the highest level. MIT's slogan is mind and hand.
Dude, you said people aren't turning wrenches. And I was just thinking, even at the Ford plant, who's turning a wrench, right? At most, they have an impact driver. You don't need to be the Neanderthal. They don't want to hire the Neanderthal, right? That's none of us do.
Exactly.
You can't even buy those tools. You can't even buy those tools. It's the funniest thing ever on a simple term, Michael. You'll get a kick out of this. The number one question is that's not the way we always did it, right? And my favorite thing is, well, I used to have 16 penny nails in my mouth, right? A handsaw and a hammer. Good luck getting a handsaw and a hammer, let alone free-floating nails. Good luck. Everyone has a tool, and it happens to be, well, you got it, right? You should hang that on the wall next to the guitar. Like, no one even has a corded tool anymore, right? Like, it came from amazing inventions of, gosh, really good segues. This is like 3 or 4 hot segues. Like, I think you could almost name it the shop class segue.
I mean, it's I like this stuff because to me, this is like I get to learn. I mean, when would I be able to talk with building science professionals about the trends of the industry from my garage? It's amazing what's going on. I'm like, I appreciate this, and then I'm going to take this. It's exciting, to me. we do have a wood shop teacher next door, and they're building like a not a tiny house, but I guess it would be like a tiny house. And I'm gonna have them watch this episode. And then with me, I'm doing car stuff, and I like learning from failure, so we break stuff all the time. It's incredible. These segues. Yeah, I don't mind getting techie about it. Yeah.
One of the best things to come out of COVID has been this.
Mm-hmm.
Pre-COVID, I was flying around the country. I would show up in a city, I'd do my lecture, I'd get back on the plane, and I'd leave. And suddenly we were all isolated, and we all started reaching out and making cool connections. Instagram's been a lot of fun, right? We've had, and it hasn't been limited to just one thing. But I taught my first semester at Boston Architectural College this year from Minneapolis.
Wow.
Right? That wasn't a thing that was happening a decade ago. And so I think I'll just throw out there for anybody who's teaching, and I guess I'll challenge Matt and Willie to join me on this one. But if any teacher reaches out and says, will you come to my classroom and talk about this subject for half an hour? The answer is yes. Because all I have to do is log into this, and there it is, right? I mean, I feel like we've got access to this wealth of information now that was so much harder to access, and it is so much less of an inconvenience for us to do it, right?
Yeah.
So, it doesn't have to be just, anyway, just that. We can do this.
100%.
We can do this in the classroom.
And you make a good point, Mike, because a lot of companies, I mean, heck, we were working on T-stud headers, and we popped Mark in real quick to do a quick demonstration and show the kids something, real fast. I've been talking with Etienne from SIGA, and they do like a online luncheon thing, and they'll do them with, builders and stuff. And what they'll do is they'll send out the kits and do the air sealing taping techniques and stuff. And so we're going to work on, we have short days on Wednesday. So we're talking about, teaming up with SIGA and having the kids do a air sealing seminar, lecture, whatever, and I mean, they're probably up by you in Minneapolis. I'm sure that's where they're going to be talking from too. I doubt they'll be talking to us from Switzerland. But yeah, I mean, that's the thing. Companies are doing this. We can connect with people like Mike. Okay, buddy. Tell Ona. Okay, I'll come tell her just a minute.
And then we have interludes like that are just so awesome.
Right?
Make it also humbling and real.
Yeah. So, okay, bud, hold on 1 second. But how when COVID hit, you made a good point, Mike. Obviously, this is how we got connected, doing this regularly. But I was talking to Steve Basic, and we were talking about other stuff for what is now this build. And then COVID hit, and he's like, "Hey, why don't you have your kids jump on? I'll talk floor plans and layouts with them. They can do their floor plans, and we'll jump on in 2 weeks." Hey, okay, you gotta wait till you're up, because you're supposed to be in bed. You're just lucky mom's not here at the moment, and dad's on this. She's with Camille still. But Steve's like, "Hey, let's jump on the computer." The kids put together their plans. We sent them to Steve. He jumped back on 2 weeks later, went through and critiqued all of them and talked about the floor plans. And I had designed the floor plan for the last house. And I said, "All right, kids, I go, here's mine. Let's see what kind of grade I get on, and let Steve critique my layout and stuff." And
awesome.
And it was all just because COVID had hit. He saved my ass because I was like, "What's a house building teacher supposed to do when we're all looking through a computer screen?" And there it was. And then it was like, oh my gosh. And then we all started talking, and other people were kind of doing similar things. And yeah, I mean, yeah, as annoying as COVID is, the situation, obviously, it definitely opened the eyes to a lot of things. And Ron definitely has talked a lot about this.
Yeah, COVID's been like the accelerator. Something I'll add that'll kind of, everybody's probably heard me say this before, but why are public schools so private? You know, it's a public school. It should be public. We should invite in professionals all the time and have exchanges like what you guys are talking about, you know? So, yeah, this is good. The kids there. Yeah, so, you know, I like all this stuff. So we're getting to the time limit here, kind of. You know, I don't want to keep everybody all night. Look, everybody's got the good backgrounds now.
That's a good one, Duke.
Yeah.
That's one of my favorites. I have a funny one with that. So, did any of you see family or friends for Thanksgiving that you might not have seen in a year and a half? Did that happen to any of y'all?
Oh, yeah.
So the question that was asked to me is, you know, what have you been doing? Where have you gone and whatnot? Right, the catch up period. And my standard answer with family was, well, I went to a Zoom room.
Yeah.
Right? It says there wasn't a restaurant, there wasn't a bar. There was a Zoom room and another Zoom room and another. And this time we have a Google Meet, which is a lot more fun than my Zoom room. So your point, Michael, is pretty dynamic of like our buddy Connor is experiencing it for ongoing period in Canada. And now you're able to be in Boston while experiencing the equivalent cold in Minnesota without the coastal. Right. So pretty awesome.
It's amazing what has happened. You know, this podcast, we were doing this about, it was kind of random. It wasn't quite once a week, and it was like a scheduled thing. It was a little bit labored. Now it's like, hey, we're just getting together. It's like, we're all going to the bar and we're going to talk about shop class. And, you know, and it's wild because we've met up. A few of us has met up at a like a maker camp over the summer, and it's like we got to meet each other for the first time. We've been talking for like 2 years. It's like, oh my god, hello. But it's great. We've built relationships and shared ideas, and it's definitely expanding, which is great.
Michael, did you see the maker camp that they went to?
I did not. No,
Ron, you got to pull that up. Like, I got to meet Duke and Nick and whatnot, like before the maker camp. And then on a Saturday afternoon or something, I opened up my IG and my chin hit the ground and I bruised my chin. I was like, what the heck? Like, when you see this maker camp, like, it is up your alley. Ron is a whiz at finding awesome things. Like, everything they did was exactly what any town USA needs. There it is.
Woodstock of Maker Fair.
There you go. Awesome. Perfect.
Let me see if we
Mark, you're right. Any like that could be done in any town. You know, it was awesome. Yeah. Every town needs that.
They basically invited in. Oh, sorry, dude. Go ahead.
Somewhere within 50 miles of where you lived. It wasn't too bad of a drive for us. But yeah.
Look at that. 144 posts, and you already hit 6,000 followers.
Yeah. So what would happen is they would pull in all these makers from around the country, basically a lot from Instagram. And I mean, this is a crazy list. Jimmy DiResta, Jesse Savage. And if you clicked on what they did, they had a full setup there. So everybody there's making stuff. This guy's got robots. Look, there's Nick. He did, that's where I got to turn the pen. He was doing the pen turning. You could make knives from scratch. You could do blacksmithing, powder coating. They built an entire frame, a timber frame. There was a certified Lincoln welder, I think. Yeah, Lincoln.
Oh, you got to show that timber frame. That structure was one of the most mesmerizing.
Yeah.
There was like 8 live action nonstop things happening.
Oh yeah, it was wild. Here it is. This is
there
the frame they built. Yeah. And they built that there. And let me see. There was you know, it's kind of
Yeah,
like
we had a timber in over the summer that we cut most of the timbers at, and then they assembled it that weekend.
that
You know,
was
and the timber in was 4 people that had copious knowledge of timber frames, and the rest of us were just, all right, we'll cut wherever you need us to cut, and everything went together. They had very little mishaps on any of the cuts. It was amazing.
That's cool.
trying to find the oh, here's the big event.
Yeah.
It's hard to see there, but they were, you know, it was pretty wild. I missed out on this one, and this is everybody went there, and there was 2 of them. There's only twice a year, right?
No. That was, well, that's the thing. This past spring and last year, they did more of a blacksmithing thing. There wasn't an official makers camp last year because of COVID and everything and
Right.
the restrictions and whatnot. But a few people did show up for blacksmithing, and then they had a
Matt,
couple
thanks a lot,
blacksmith
Matt. We'll
events
see you
over the
soon.
summer. Or over
Yeah,
the
yeah.
spring.
Hey, sorry I had to kind of get in late and cut short tonight, but it was just
No
a busy
problem.
night. But I was super pumped I was able to get on here. Michael, so glad to actually connect in a
Yeah.
talking situation. Yeah, awesome. And Mark, I talk to Mark all the time. So, and Mike, thanks for tagging me on your deep thoughts. You guys are gotta make sure you follow Mike on Mike's. You know, we talked about SNL's. What was it? The deep thoughts or whatever.
Oh yeah.
Mike does some good thought things every week. They're good. So, but I'll catch you guys next week. Mike, great getting to meet you this way. And then Mark will talk soon. And the rest of you guys, we always talk. So,
Yep.
Very cool.
all right, you guys have a good night.
Awesome.
All right. See you later.
I am gonna have to bug out and pretty soon here as well. I've got
No problem. This was good.
Time.
Oh, this was the maker camp. I got some photos of my own here. And the crazy thing about it, real quick before you leave, is they lit this insane sculpture on fire at
Yep.
night.
Oh, cool.
This crazy, look how big this thing is. And they lit her on fire, and it was like this plywood dinosaur. And
You can actually buy that now.
Oh,
42.
no kidding.
Yeah, the 42 Fab guy that was doing the welding, he made a flat pack of that. So a little rocket stove.
It's a rock. It was a rocket stove the size of a building.
Yeah.
That's cool.
So
Yeah.
so if you buy that, Nick, what's the scale flat pack of that?
That's the thing. 42 Fab, he designs flat pack stuff. So like I bought some rocket stoves from last year, and they'll fit in a 9x12 postal bubble mailer, and that's how he mails everything out to keep postage down. And then you weld it when you get it home.
Oh, so okay. This is
So that's what I mean by flat pack. He's plasma cut all the pieces that you'll assemble and then weld together to make that.
got it. When I picture flat pack, I picture 4 semis coming up.
Oh,
and-
no.
Got it.
So
This
that
is
rocket
it.
stove that was just up on the screen,
I was like, what is that thing? Like 85K?
There it is.
Got it.
Nice.
That's
This is
awesome.
great.
That's so cool. I want one.
Oh, yeah. It really is a rocket stove. It's
Yeah.
not a giant.
and that's the idea of what they designed out of the wood. When they
See, I could see Michael Nick doing a flat pack of the giant dinosaur that you erect and burn and have your local fire department on hand to put out the torch if the elm tree lights
they
up.
didn't have any firemen there the night of that.
Well, you were there, so you're good.
That'd be a fun build.
Wow, S'morezilla Maker Camp Dinosaur, $55. I feel like we should buy that for Matt and only give him like 80% of the parts and then act confused when it doesn't come together.
Oh man, this was really good. What a good! We always have such a good time here. I really appreciate everybody coming in. Michael, Thanks for taking the time. I never got to my question of how you got to this industry. Maybe some other time, maybe next time.
I'd happy to show up again and answer the rest of the questions.
Okay, yeah. But this was great. I mean, I think we covered the goal is to bring people together and then record it in case people missed it. That's basically it. Sharing ideas, building relationships. That's really it. And that was accomplished, so we're good.
That's awesome. Awesome to meet everybody. See some of you guys in person. This is it's a blast. So
nice. All right, cool. Thanks a lot.
Yeah, we'll see you guys out there.
All right. See you later. Thanks a lot. Okay, we're gonna end the recording here. And yeah, I appreciate everybody coming in.